Picture this. You're just minding your own business, scrolling through your feed when, bam, you're staring at a churning, rushing river that looks, well, exactly like bright red blood. You kind of have to pause and squint, right? Like, did someone just dump millions of gallons of dye in there? Is it CGI for some new apocalyptic movie? Look, if you thought that, you're absolutely not alone. This wildly surreal phenomenon has practically broken the internet. So, in today's Explainer, we're going to unpack exactly what on earth is happening up in the high-altitude peaks of South America to create this mesmerizing and, let's be honest, slightly terrifying sight. Okay, let's dive into this, because when you first see this footage, it literally looks like it was ripped straight out of a horror movie. I mean, we're talking about a deep, intensely opaque crimson waterway just violently carving its way right through a lush green mountain valley. It completely messes with your head, right? It challenges our basic understanding of what nature should look like. We all know rivers are supposed to be blue or brown or maybe green, but this intense shade of red? No way. And yet, as impossible as it seems, we're looking at a very real, very physical place right here on our planet. This specific footage actually went incredibly viral recently. It was captured and shared by outlets like Z News, and it racked up over 3.5 million views in no time at all. People scrolling by were just completely baffled. But here's the thing. While it's a new internet obsession for us, this spot is located deep in the Andes Mountains of Peru. And to the locals, it's not a mystery at all. It's actually a well-known geographical feature. They call it Pucamayao or Yawarmayo, which literally translates from the indigenous Quechua language to, you guessed it, Red River. So where exactly is this mystery flowing? To find it, we actually have to head down to the Cusco region of Peru. Specifically, we're looking at the Kenchis province. It's nestled way up in these high-altitude peaks, right along the same route people take to get to Rainbow Mountain. Now, the absolute most crucial piece of context for this whole environment is 4,200 meters. To put that into perspective, that's nearly 14,000 feet above sea level. We are talking about the intensely rugged, high-altitude environment of the Vilcanota mountain range. Up here, the air is super thin, the weather is wildly unpredictable, and the landscape is just raw. It's a place where extreme geological forces are pretty much constantly at play. But you know what makes this river even more fascinating? It is an absolute master of disguise. Seriously, if you were to hike up to this exact spot during the dry season, you wouldn't find a blood red river at all, not even close. You'd actually find this peaceful, crystal clear stream with a really beautiful greenish hue, just like the other rivers around the Vilcanota region. But everything changes when the seasons shift. Between November and April, these massive, heavy monsoon rains absolutely batter these mountains. And it's that intense seasonal rainfall that acts as the trigger. It literally transforms the clear green water into that opaque, mineral-rich red torrent that broke the internet. So, how exactly does rain turn a whole river red? Well, to figure that out, we have to unlock the deep-time chemistry of the earth right beneath our feet. Because the secret to the Blood River? It's actually hidden entirely within the rocks themselves. To really crack this case, we're looking at a dense but honestly, absolutely brilliant geological paper by George Edwin Dorsey. It's called The Origin of the Color of Red Beds. Dorsey basically dedicated his work to understanding why certain ancient rock formations, which geologists actually just call red beds, have this incredibly vivid crimson coloring. And as he points out, the entire mystery begins and ends with how one specific element behaves over millions and millions of years. That element? Iron. So the crucial point is, iron is everywhere. As Dorsey notes in his paper, iron is present in practically all rocks. It is an incredibly common element on the Earth's surface. And, more importantly, it is more than an adequate source of supply for this red pigment. Think about it. It's the exact same reason a forgotten bicycle left out in the rain turns rusty red. It's just iron doing its thing. But wait a second. That immediately begs a pretty massive logical question. If iron is practically everywhere in the Earth's crust, why aren't all mountains red? Why doesn't literally every river in the world turn into a river of blood when it rains? What specific chemical reaction sets this isolated red valley in Peru apart from, just ordinary mountain ranges? Now, what's really interesting about this slide is how it answers that exact question. We have to look closely at the behavior of iron oxide. It exists in this whole family of compounds called sesquioxides. And the main difference between them isn't actually the iron itself, it's the amount of water trapped within their molecular structure. Depending on their level of hydration, these iron oxides produce vastly different colors out in nature.
Let's simplify the dense science here for a second. When iron oxide contains a high amount of water, it forms a mineral called limonite. Limonite gives rocks this kind of dull yellow or brownish color, which, if you think about it, is exactly what we see in most ordinary non-red rocks all around the world. But when iron oxide completely loses its water, when it becomes entirely dehydrated or anhydrous, it transforms into a mineral called hematite. And hematite acts like a highly concentrated, brilliantly red pigment. Just a tiny amount of this dehydrated hematite can dye a massive amount of surrounding rock.
So, how on earth does this dehydration actually happen? Well, listen to this quote from Dorsey because he hits the nail on the head. Ferric hydrate will lose its water and turn red spontaneously if given time enough. This is definitely not something that happens overnight. This brilliant red Peruvian landscape is the result of deep, unimaginably vast geological time. We're talking millions of years, where the iron in this specific valley spontaneously shed its water molecules, basically transforming the very mountains themselves into towering deposits of concentrated red hematite.
Which finally brings us to the last piece of the puzzle. We have a valley made of highly concentrated, dehydrated red rust. Now, during the dry season, it just sits there. It's just a beautiful, red-hued mountain range. But when those intense seasonal rains hit between November and April, you get massive soil erosion. The heavy rainwater washes all this loose, red hematite pigment right down the mountainsides, funneling it directly into the local streams. So rain plus hematite equals the Blood River. It is, quite literally, millions of years of rust being violently washed away all at once. But while this makes for an absolutely spectacular visual for us scrolling on social media, we really have to consider the ecological stakes here. Like, what actually happens to the wildlife when their usually crystal clear home suddenly turns into a raging river of opaque iron? Imagine being a fish living in these high-altitude waters when November rolls around. That sudden influx of iron oxide minerals causes an immediate, dramatic change to the ecosystem. The fish experience heightened stress because their habitat is fundamentally altered. I mean, the biggest immediate threat is the sudden opacity of the water. The fish essentially experience the sort of predatory blindness. They can no longer see predators coming, and they definitely can't easily hunt for their own food in that murky red water. Because of this intense environmental pressure, a lot of fish are basically forced to flee. They have to relocate upstream or find less affected tributaries just to survive until the dry season finally comes back. Let's move to and see how this builds into actual travel logistics. Because if you want to witness the Red River in person, and you're daring enough to visit, it requires some very serious preparation and a whole lot of respect for the Andes. Here are the absolutely crucial safety steps you have to follow. First, check local weather alerts for storms. The very same heavy rains that create this incredible Red River also bring incredibly dangerous high-altitude thunderstorms. Second, you want to plan your visit for the early morning, definitely before 11 a.m., because storms up there typically roll in during the afternoon. Third, pack serious waterproof gear and sturdy hiking boots. Remember, you are hiking in a monsoon at 14,000 feet. And finally, if it starts raining heavily or you hear thunder even twice, seek immediate shelter. At that altitude, lightning strikes are a severe, immediate threat. Which leaves us with one final provocative question. We know it's not actually a river of blood. It's a masterpiece of millions of years of deep-time chemistry, seasonal erosion, and just staggering altitude. But knowing the physical toll it takes to get there, and those very real dangers of the high-altitude thunderstorms required to even see it flow, is the reward of witnessing this fleeting, raw, untamed power of the Andes actually worth the risk? Well, that's a question only you, and maybe your hiking boots, can answer.